If you've been following along, you know that Rust is super strict about borrowing rules. You can either have one mutable borrow or multiple immutable borrows, but not both at the same time. And normally, these rules are enforced at compile time. But sometimes you need more flexibility. Sometimes you need to be able to mutate data even if it's behind an immutable reference. And that's where RefCell and the concept of interior mutability come in. Let's start with the basics. Imagine we have some data inside a struct, and we want to change it, but our struct itself is not mutable. Sounds impossible, right? Well, with RefCell, it becomes possible. Here's a really simple example. Okay, let's break this down slowly. We're creating a RefCell that holds an integer 5. Normally, if we had just a regular let data equals 5, and that variable wasn't declared mutable, we wouldn't be able to change it. But with RefCell, we call borrowMute to get a mutable reference at runtime. Then we dereference it with the asterisk operator and add 10. Finally, we call borrow, which gives us an immutable borrow, and print the value. So the output here will be 15. Notice what just happened. We mutated the data inside RefCell, even though data itself was never declared as mute. That's interior mutability in action. Now let's take a step deeper. The key thing to understand is that RefCell enforces borrowing rules at runtime, not at compile time. This is different from normal Rust references. Let me show you what happens if we break the rules. If you try to compile and run this, it'll compile just fine, because the compiler trusts RefCell. But when you run it at runtime, you'll get a panic. It'll say something like, already borrowed, borrowMute error. So with RefCell, Rust says, okay, I won't enforce the borrowing rules at compile time. But if you break them at runtime, I'll panic and crash your program. That's the trade-off. Flexibility at the cost of possible runtime errors. Now, where is this actually useful? A really common case is when you're working with structs that need to be shared and mutated across multiple owners. For example, if you combine Rc, reference counting, with RefCell, you get shared ownership and interior mutability at the same time. Let me show you. Here, we've got an Rc wrapping a RefCell that holds the number 100. We clone the Rc into A and B. Both A and B can borrow mutably, because they're borrowing through the RefCell. We add 50 from A and 25 from B. The final value is 175. This is super powerful because normally, if you had an Rc holding an integer, you couldn't just mutate it easily, since Rc only gives you immutable access. But wrapping it in a RefCell gives us that mutation ability, while still sharing ownership. Let's take another example to make this crystal clear. Imagine we're building a simple graph structure where nodes can point to each other. Each node needs to be shared and maybe mutated too. That's the classic case for Rc and RefCell. Here we've created two nodes, one with value 1, one with value 2. Then we say that the first node's next points to the second. And because both first and second are Rc of type RefCell of type node, they can be shared across multiple owners and mutated even if the original variables are immutable. This is a very common pattern in Rust for building linked structures like graphs, trees, and so on. Now let's talk about a little nuance. RefCell only works in single-threaded code. If you try to use RefCell in a multi-threaded program, Rust will complain. That's because RefCell doesn't implement sync. But don't worry, there's a cousin for multi-threaded situations, Mutex and RwLock. They serve a similar purpose, but with thread-safe guarantees. So think of it this way. RefCell, runtime borrow checking, single-threaded. Mutex or RwLock, runtime borrow checking, multi-threaded. Let's wrap it up with one more example, just to get the idea. What if we try multiple immutable borrows? Is that okay? This is perfectly fine. You can have multiple immutable borrows at the same time. The rule is the same as usual Rust references. Many readers or one writer, but not both. The difference is with RefCell, that rule is checked at runtime. So, to summarize, RefCell is your tool when you need interior mutability, the ability to mutate data even through an immutable reference. It enforces the borrow rules at runtime instead of compile time. And when combined with Rc, it becomes a really powerful way to create shared mutable data structures. Experiment with RefCell, try breaking it, and really see those runtime errors. That'll help you internalize how it works.